Welcome back. So kind of creeping up on explosivity. So fissure and shield volcanoes, very low on the explosivity scale. Kind of the next step up is when we get into small little cone-shaped volcanoes, called cinder cone volcanoes. They're built from an accumulation of tephra. Tephra is small or large pieces of ejected volcanic rock fragments. So when a volcano erupts, you usually get a few things. Lava, tephra. So lava is the liquid stuff that comes out. Tephra is the rocks. Ash is the very fine tephra. And gases. That's usually what comes out of a volcano. So tephra is just all the rock pieces that come out. So the cinder cone volcanoes, it's built up from small pieces of tephra, very small little ejected volcanic rock fragments. These types of volcanoes are common around larger volcanoes, normal faults, or along cracks or fissures. They don't usually stand out on their own. They're usually kind of little side vents to other bigger volcanoes. Usually. That's not always the case. Sometimes they are by themselves, but usually they're kind of surrounding bigger volcanoes. Some great examples, of cinder cone volcanoes are SP Crater in northern Arizona, Paracutin in Mexico, Sunset Crater, also up in Flagstaff, which was the most recent volcano that erupted in Arizona about 1,000 years ago, right around 1,000 years ago. So cinder cones exhibit a strombolian eruption, moderate bursts of expanding gas that eject little clots of incandescent hot glowing lava in cyclical or nearly continuous small eruptions. So here's a picture of a strombolian eruption. So each of these little strings is a little piece of tephra that's ejected out. So it usually, the material that's ejected out is just small little pieces. There's a lot of built up gas in these cinder cone volcanoes and strombolian eruptions. So these little blobs of lava get shot out, and they're so small that they pretty much cool in the air. For the most part, they cool in the air or cool pretty close to when they hit the ground. So there are all these little small pieces, these little small cinders. Hence the name cinder cone volcano. And these little pieces are jagged and sharp, and so they build up these very steep cone-shaped small little volcanoes. Here is SP Crater. I'll leave it up to you to kind of research what SP means, but it's an interesting name. So this is SP Crater north of Flagstaff. You can drive to this. In fact, you can park right around here. And if you do go here, I would suggest taking this kind of jeep trail up and then hiking up the rest of the way. This is a cinder cone volcano made up of very small cinders, so it's kind of like walking up a big pile of sand, like sharp, jagged sand. If you ever walked up a sand dune, how kind of hard it is, like you step and you go backwards, you step, and you kind of slide down. Same with these, except it ain't nice soft sand. It's jagged rocks, small little jagged rocks. And they get in your shoes, and then they're all sharp, and they cut your feet. So it's a great climb. It's a heck of a hike for how small it is. It's a heck of a hike. But it is a volcano nonetheless here in Arizona. So this is the cinder cone, and then as this cinder cone was dying, there was a later lava flow. So you can also see lava flow featured in this area. Here is Paracutin, same thing, cone-shaped, not very big. These are relatively small volcanoes, maybe 1,000 feet or so. Relatively small. But again, with this one as well, steep sides and then a lava flow was created as it was dying out. Same with Sunset Crater, also just north of Flagstaff. This one is very accessible. This is in Sunset Crater National Monument. There's hiking trails. You can't hike to the top of this one. SP Crater is on private ranch land, but you can still go to it. You can climb that one, but not this one. They don't want to degrade this volcano, but there's other trails you can take, and here's a big nice lava flow that came as this cinder cone was kind of dying off. It's kind of its last gasp to kind of just have a little lava flow as it's dying. So those are cinder cone volcanoes, relatively small. Creeping up in explosivity and pretty darn explosive are stratovolcanoes, sometimes known as composite volcanoes. They are created from andesitic magma, which is kind of intermediate in silica, therefore kind of in the middle with viscosity, so kind of sticky stuff, and therefore in the middle with volatile content, so kind of a medium gas content amount. And because of that, because the magma is a little sticky, it kind of moves a little slow, so it can build up pressure, and it can trap all that gas. And once there's enough pressure, it can cause the volcano to explode. These are stratovolcanoes are known for kind of these singular, tall, scenic mountains. 60%, around 60% of the Earth's individual volcanoes are stratovolcanoes. They can be extremely explosive. Even though they make up around 60% of Earth's volcanoes, they're responsible for over 80% of eruptions. And these types of volcanoes are actually responsible for most of the deaths and destruction in the world. Composite volcanoes, which we'll maybe talk about here in a little bit, well, they're bigger eruptions, and if they did go off, they could kill many more people. They just don't happen that often. They don't happen, but every maybe 100,000 years or so. Where these erupt all the time. These erupt all the time. These types of volcanoes are very common in the Ring of Fire and other convergent boundaries. Mount St. Helens and Mount Rainier in Washington State. The San Francisco Peaks, right up here in Flagstaff, that is an old stratovolcano. Mount Fuji in Japan is another stratovolcano. So when most people think volcanoes and what they look like, this is what they're picturing. They erupt differently. You have Volcanian eruptions, moderate explosions of gas laden with some ash. You have a Palaean eruption, explosive outbursts that generate pyroclastic flows. More on that in a little bit. And then you have a Plinian eruption, intensely violent, enormous, nearly continuous jetting blasts that core out the magma conduit, rip it apart, collapse the volcano. So, smaller eruption, biggest eruption, kind of in between, and then you get this weird, something called a pyroclastic flow. More on that in just a second. So here's a Volcanian eruption. You don't really get a lot of lava out of here. Tephra, ash, gas, yes. Lava, no. Here's a Palaean eruption with one of those pyroclastic flows. You still get some stuff going up into the atmosphere, but then you get this other material coming down. And then you have Plinian eruptions. These things that look like the end of the world. Large amount of tephra and ash and gas getting pumped up into the atmosphere. This is Mount St. Helens. So this is what Mount St. Helens looks like now. It's still very much an active volcano. This is just steam coming out. But after Mount St. Helens blew its top, this is kind of what's called a resurgent dome, a resurgent volcano. It's kind of coming back. So Mount St. Helens is very much alive. So what's interesting about composite volcanoes, you can figure out about how tall they were based on what are called their flank, their sides. Looking at the angle and kind of imagining where these would meet, you can kind of recreate what that mountain looked like before it blew its top, for the most part. So all of this material was blown out, and then everything in the magma chamber. So that's Mount St. Helens, stratovolcano. Mount Rainier, another stratovolcano. This has not erupted in a while. If it does erupt, it wouldn't erupt like Mount St. Helens, even though they're kind of in the same location. They're along the same boundary that created these. They're only a couple 100 miles apart. You can see one from on top of the other. But it just wouldn't explode as bad as Mount St. Helens. It might be more Volcanian just due to some other underground tectonic activity and geology. And then Mount Fuji in Japan, just outside of Tokyo, another stratovolcano. These make for very scenic mountains, and people love to climb them. I've climbed Mount St. Helens. I've climbed Mount Rainier. I've not been to Japan, but I would climb Mount Fuji. These are all volcanoes. Speaking of climbing, right here in Arizona, if you want to climb a mountain, the highest elevation mountain is in the San Francisco Peaks, just up in Flagstaff. Composite volcano. Again, this is where it erupted. The last time it erupted, it's extinct now, so the chances of coming back are very low. But again, just kind of follow the flanks of the volcano up, and you can imagine how tall the mountain once was. So here is the San Francisco Peak, San Francisco Mountain, which is an old extinct composite or stratovolcano. And then all these other little dots all around here, these are all cinder cone volcanoes. These are all cinder cone volcanoes. So here's SP Crater. You can take 89 north of Flagstaff and kind of drive through some ranch lands. You drive through by a bunch of, these are all, again, cinder cone volcanoes. But SP Crater is kind of a very world-famous one. It's like on the covers of textbooks. And, you know. Sunset Crater, part of Sunset Crater National Monument, right off of the 89 as well. This one's a little bit more user-friendly, hiker-friendly. A cool little park. Sunset Crater National Monument. There's also native ruins. There's a lot of cool things to see besides volcanoes. But yeah, everything that you see here is pretty much all old cinder cone volcanoes. And in fact, there's over 600 plus volcanoes in the San Francisco volcanic field. That's the area around north of Flagstaff. It's a lot of volcanoes. For the most part, it's pretty much done. But you never know. This was all caused by a hot spot. Some mantle plume formed underneath Arizona millions of years ago. And it fed up into the surface, fed melted material, and fed that magma and lava up to the surface. If there were to be another eruption in Flagstaff, it wouldn't be the main big mountain. It would be somewhere over here, most likely some sort of cinder cone volcano. More on that in lab, I believe. So let's go ahead and pause here. When we come back, we'll talk about one more type of volcano, the biggest explosive type of volcano. That would be super volcanoes. I'll see you back here in just a second. Excuse me.